Right, this evening I'd just like to show you this excellent new chuck which I've just received from China from the Sanu company. It's the Sanu K11-130 and it's a 3-jaw self-centering chuck, and it's 130mm in diameter, and it's the biggest Chinese chuck that I've got so far. It comes in this box here. It says #1 quality, which it surely is. It comes with 2 sets of jaws, 3 Allen bolts to secure it to a back plate, and a really nice, well finished chuck key. And I knew what I'd be getting in the way of quality because I have one of their chucks already. I have the Sanu 80mm self-centering 4-jaw chuck, which I use for a screw tapping chuck on both lathes. And like I say, when I received this one, I wasn't surprised that it's absolutely brilliant like that one. And I'll be using this one on my Machifit lathe. The largest chuck I had on there so far is the 125mm, so I'm replacing it with this one here now. The 125mm one I'm going to use on my Chinese mini lathe. And when I made a back plate up for this, put it on the machine, it ran within 1 thou. I haven't had to do anything to it. I had a look inside to have a look what the quality was like and see whether it was clean, and it was perfect. And I'll show you in a minute just inside what it's like. So I always mark the chuck up before taking it apart so I can put everything back in exactly the position it was found in. Just take these 3 crosshead screws out the back here. Very close fitting. And there you can see inside. And then use a soft metal drift just to knock the scroll out evenly. And you have to do this for cleaning of these chucks periodically. So you can see the scroll is nicely machined and everything's ground perfectly. And like I say, when I got it, I only just took the back off. This is the first time I've actually taken it apart, and you can see it's nice and clean and ready to go straight back together again. And that's how easy it is to take a 3-jaw chuck apart for cleaning. And the jaws are nice and clearly marked up on one side, 1 to 3, and the chuck is marked just inside here, 1 to 3, for the jaw positions. And all their chucks have a nice button oiler on the front here, which makes it easy to actually oil the scroll. And it's lovely and smooth over the full travel. And the jaws are nice and tight, there's no side movement whatsoever. And like I say, when I put the chuck on the back plate that I made, put it on the machine, they run within a thou. And this Chinese company make a nice range of different size chucks, all of the same quality, and the links for those different sizes will be shown below. And you can buy them direct from that link, and you'll find that they're really reasonably priced. Now, when I got this one, being 130mm in diameter, I was a bit worried at first because I went on eBay and I couldn't find anything of that size in cast iron to machine a backplate up. So, like I say, I was a bit worried. I could only find like 125mm, and I had to think about it. And to get myself out of trouble, I thought again of using one of these weightlifting weights. It's a good size, it's really nice cast iron and really nice to machine. And when I say it's nice to machine, what I mean, it's nice to actually cut. Cast iron is a very messy material to actually machine, and a lot of dust comes off of it. What I use is a fan to blow the dust away from me when I'm machining it, and sometimes I actually wear an actual mask. And if you've machined cast iron before, you'll find that it gets absolutely everywhere black dust. What I do is I do each op on this weight, and after each operation I hoover up completely. I also cover up whatever I can in the vicinity of the lathe with polythene sheeting, and it is actually best to machine it dry. So now I've found that these weights are excellent for a number of things in the workshop. They're great to collect if you go to car boot sales or whatever. Buy them up as cheap as possible and save them up, and you'll be surprised at how many times you use them for various different fixtures and back plates. So if you're new to machining, the first problem that you have with machining one of these is the round diameter and the thickness. There's no way that a set of jaws can hold that safely to machine it. So what you need to do is make a mandrel up. You make them out of a piece of bar end scrap, thread it through the centre. It's a close fitting mandrel, so it pushes in the bore like that, and then I have a threaded end with a disc of brass on there, and screw that one up nice and tight so it clamps it in between. I can actually tighten that disc down as well if I want to, or you could actually just make that in one complete piece. Tighten it up. That has a centre hole there, so this is held in the jaws of the lathe, and then you put a running or a live centre in this end here, and that'll hold it very nice to actually machine this diameter here first, so you get it nice and flat, and face off so you get a nice square end, and then you can turn it round and hold it safely in jaws. And over the years I've made up loads of different mandrels. I keep them in a drawer like this. I've made some out of plumbing fittings, these ones here that I use for the ball turning, so save them all up and you'll be surprised at all the different types of work you can actually hold with them. So now I'll just show you a few machining ops of this cast iron weight on the Machifit. So after the machining ops, just imagine this to be a solid cast iron disc with no register on the front of it, or this bore here. I got an old Machifit back plate with the Machifit thread in it. This one had the holes in here already. I turned this one down to 100mm. I then put this one back in the Machifit and bored this out to a very close fit. I used a transfer punch and drilled those holes through with a core diameter for an 8mm thread, and then tapped those nice and square. This one then drops into that and align it again with the marks, and I used stainless steel 8mm Allen bolts and tightened those up nice and tight and even. I then screwed this onto the Machifit spindle and turned the register, and that one has to be a perfect fit on the chuck. Now, in the past I've actually avoided chucks like this with just a securing hole on the back of the chuck to screw the back plate on. I've always gone for chucks where there's a hole for the bolt that goes right the way through, and this is because in those days I used to think, well, I can just put that onto the register and then use a transfer punch through those 3 or 4 securing holes and get an indent and these holes in the correct positions first time. So if you're new to machining back plates, or you're limited to a bench drill like I am, don't be put off by these securing thread holes at the back here like I was. There's a very easy method to actually get the holes in the correct positions, just as easy as using a transfer punch with the through holes. And I've shown this method before. You just buy 3 stainless steel grub screws, the same thread as what's on the back of the lathe. In this case it's 8mm. On these grub screws you'll find that the top edge is fairly sharp. You screw these into the back of the chuck and you screw them down so that there's about 10 or 20 thou protruding from the back face of the chuck. They must be all equal, so either sight them up. If your sight is good you can get them equal, or you can actually put a depth mic on there and measure them so they're all dead equal. You put the back plate register in the chuck, and then put this on a nice hard wooden surface or a metal surface, and put a brass block on there or a good solid wooden block, and then use a heavy copper mallet to give it a bit of a whack. And I'll give you a bit of an example. I've measured these so that they're all protruding by 20 thou. The chuck is on a hard wooden surface over a good solid bench vise. I put the register into the chuck, a piece of thick brass on the back there, and use a heavy copper mallet to give it a nice solid whack. And that won't damage the chuck in any way. When you lift off the back plate, you'll have 3 clearly marked circles. And then you can use those to use an ordinary centre punch in the centre of those, and then do an indent in the middle, centre drill it on the bench drill. You can do a pilot drill if you want, and then the clearance drill for the 8mm Allen bolt. And that method has worked every time for me without fail. And it's worth having a few of these stainless steel grub screws around just for this purpose. And each time you do a chuck, which won't be very often, you can actually use a new grub screw with a very sharp edge. But those there are still as sharp because the cast iron is quite soft. Next I screw the back plate on and test it on the machine for concentricity. If there is more than a couple of thou, or even more than 1 thou, I'd actually swivel this round in another position and try it. And then when you get the optimum position, this one was a thou, like I said, I mark it up with a 0 and a 0 on this keyhole here, which is adjacent to the oil button. And this is the best actual Chinese chuck that I've ever bought for concentricity. And when it's on the machine, you can give those a good tighten up and hold the chuck key in the chuck like that while you do it. And just one other thing, if you have the Machifit indexing back plate, the original one, and you drill this new one, make sure when you're actually drilling it that you start off in a position which will actually clear the Allen bolt, otherwise you can actually drill down into that Allen bolt. I check it first, put it on the lathe, put the back plate in the chuck, and then check with the pen and go all the way round just to see that I'm going to clear all those Allen bolts. And if you have a 3 hole fixing like this one, you can actually get it to clear. So the holes are either side of those fixing bolts. So if you want a really high quality chuck like this, check out the links below, and if you buy one, you won't be disappointed.